Okay, so here is the video I promised about the formatting guidelines. I've completely updated them and made the examples kind of go along with the Excel, so that way maybe it'll make a little more sense this way. Okay, so first up we have our t-test. So no matter what type of t-test you're running this semester, you're going to make a bar graph. And remember, a t-test is comparing two groups. It could be the same group that you're testing twice, which would be a paired t-test, or it can be an unpaired, where then you will do the f-test for variance again, and then you will determine if the variance is equal or unequal, which will then tell you if you're running a homo or heteroscedastic t-test. However, no matter which type of t-test you run, this is the format that you are going to use. You are going to have your two bars that are representing the mean of each group. So in this example, we're looking at heart rate between two groups. Now, this is two separate groups, so notice that we do have the two separate ends. So in the meditation group, there's a different amount of observations than in the no meditation group, excuse me. So for this example, we can see that students who meditated had a lower heart rate than those who did not. So when you report this, you need your brief title, the type of test you ran, okay, heteroscedastic t-test, the p-value, which tells us the significance of this test, the n for both your groups, since they are different in this case. Looks like in the first group we had 20 people, and in the second group we had 15. So I don't really care how you denote the difference, but as long as you have the two separate n's. Now, if we were doing a paired t-test, you would just need to have one n. Okay, and this should make sense because it's one group that you are testing twice. All right, so a couple final things here that you need to include, your error bars here. Make sure that when you are in Excel, you are making custom error bars. Since Excel, unfortunately, if you just click add in error bars, it will just give you a standard deviation of 1. And that's not what we're looking at here, right? We are looking at the standard error of the mean for our error bars. So unfortunately, you do have to make them yourself. And there are separate YouTube videos that I posted on how to do that. And one last note here, you do not need to include the statistics from your F test. So when you're doing the paired t-test, there's no F test. But when you're doing an unpaired, you don't need to include the numbers, which is basically going to be a p-value, from your F test. All you need to state is which test you ran, and that already kind of tells me what your results were of the F test. All right, so here's how you make a perfect graph for t-test. Okay, moving on to a correlation. So when you are looking at the association between two variables, you can run a correlation. Now, the correlation is different than a regression because a correlation is looking at two dependent variables, two uncontrolled variables. And for that reason, the only thing we're really going to look at here is going to be the R, or the correlation coefficient, and the p-value. So what you are looking at here is the number of murders here on the x-axis, and then on y, we have the age in years. Now, it doesn't matter which is on the x and which is on the y, okay? Either way, you're going to get the same results. And again, there is no dependent and independent variable in this situation, so it doesn't really matter. So we have our brief description here of what's going on. We've stated that it's a correlation. Since it's a correlation, we're going to have a p-value, which tells us if is there significance here. Then we are going to have our R value, which tells us about the trend. So this R value is 0.89. So that is very close to 1, okay? And since it's positive, that tells us that this is a positive correlation. And the 0.89 tells us that it's a strong correlation. And then, of course, we have our N, which is the number of observations. And that's all the information that we can gather from a scatter plot when we're doing this for a correlation analysis. So one common mistake I saw was people looking for means here. There are no means in this situation. We're just looking at two variables and seeing if there is an association between the two variables. All right, so now let's move on to our scatter plot with the regression line. Again, this should only be run for a regression. Now here we're looking at a relationship between two variables. We still have our scatter plot with the number of observations. In this case, we have 10, so there should be 10 dots. Then we have our line going through it, should go through basically half and half on the top, half on the bottom. But again, in Excel, it will do it for you, so you don't have to worry about that. So we have our points for the observations, our labeled axes, and then our linear trend line through the points. Because we have the trend line, we have our formula here, our y equals mx plus b formula, telling us about this trend. And it's really showing us how well, well, sorry, not how well, but it's telling us if we put in a certain value for x, we will get an y output, and it should line up on this trend line. So if we wanted to input a value that wasn't already given to predict the y, we could use that formula to do so. Now, the other important metric here is going to be the r squared value. Now, the r squared value tells us how good this formula is at predicting the output. So the higher the r squared value or the closer to 1, the better your model is at predicting the results here. So for this example, we have the time studied on the x-axis. And in this example, we could say that the time that a student study was controlled for. We could control for this. We could say, okay, student A, you cannot study more than 4 hours. You have to do exactly 4 hours of studying and then you must stop. No more, no less. Not realistic, I know, but this is just to show you an example. Okay, so we could control the time studied, and then our result or the output would be their test score. So the controlled variable is going to be on the x, which is our independent variable. And then the dependent variable test score will be on the y. And this will show us, okay, if we put in, say, 8 hours of time, what does this model predict that this student will get as their test score? Okay, so that's what this formula is telling us. And then again, for your figure caption, we have regression. We need a p-value telling us if our results are significant or not. Our r squared, our y equals mx plus b formula, and then finally our n. And again, for this one, we would just have one n since we're just looking at the relationship between two variables. All right, so that is our regression. Remember, the difference between the two, correlation and regression. Correlation is looking at an association, and it uses the little r. A regression is looking at the true relationship between two variables with a control, and it is going to give us an r squared value and the formula. Okay, now the last type of graph we could do is a line graph, and this one is the easiest because you don't have to run any stats for this guy. The prime example I could think of here is going to be looking at blood serum or blood glucose, hormones in the blood, things in the blood we like to look at. So in this case, we're looking at blood serum estradiol levels over a 120-minute time frame. So the X will always be the time, since that's what we're looking at, over a period of time. Then on the Y, we are graphing how much, in this case, estradiol is in the blood at that point in time. So all you'll do is place a dot at the said time points and then connect all the dots. and Excel will do this for you, okay? But connecting all the dots so we can look at the trend. We want to see basically, here's the starting point at 0. We're going up. Looks like there's kind of a plateau and then a slow downward trend, and looks like it's plateauing out again. So that's the kind of information we're going to get from a line graph. It's just going to kind of give us a trend, and we're going to make some type of assumption or some type of prediction about what that means. And then for your figure caption, again, just figure whatever in bold, and then a brief description of what you are seeing. All right. Now, lastly, the last type of figure I could ask you to do would be a table. Remember, you don't have to do a table unless it's specifically asking you to make a table, and it will always tell you what to include in that table. So it should look something like this. You need to have the, obviously, what you're looking at here. The n value would be the next column. Okay, and actually, the order doesn't truly matter over here as long as you have these three things or whatever it's asked for in the instructions. But this is a pretty standard outline that you'll see here. So a column for your ends, and then a column for your means with your standard error of the mean in this format. So mean plus or minus standard error of the mean. And then there will be an associated p-value that was calculated as well. And it's okay if it's the same. It probably will actually be the same, and that's completely fine. You'll just repeat it per each row. Okay. In terms of the caption, for tables, the table caption should actually go up on the top, whereas before they should be on the bottom. But you'll just bold the number and then make a brief caption. All right. The last thing for the tables is just make sure that they're outlined, like so that you can see clearly the differences in the grids. Um, but the coloring, I don't really care. You can make them different colors. Just make sure that every box is outlined, just so it's clear. All right, so here are your outlined formats that you can do this semester, and hopefully this helps clarify.